section 4-5 in the book. We're going to cover quite a bit in this video, but the first part is going to be evaluating the determinant of a 2x2 matrix, and then we're also going to talk about the multiplicative identity and the multiplicative inverse of a matrix. So we're going to verify that two matrices are inverses of each other. We're going to figure out how to find the determinant of a 2x2 matrix. We're going to be able to find the inverse matrix, and then we're going to use that inverse matrix to solve matrix equations. So that's what happens in this video. Alright, let's get started. On this page, I want you to recognize this I3, that stands for the identity matrix for a 3x3 matrix, for a square matrix. And what an identity matrix is it has ones in the diagonal and zeros everywhere else. So this is the identity for a 3x3 matrix, and this is the identity for a 2x2 matrix, ones in the diagonal and zeros everywhere else. Okay, so the first thing I want you to do is I want you to find what A times the identity matrix is. Multiply A times the identity, and then do it the other way, because again, order matters with matrix multiplication. We learned that in a few lessons ago. So the identity times A and A times the identity. I want you to do it both ways, and then do the same thing. Do matrix B times the identity, and then do the identity times matrix B, and come back and hit play on the video and see what you should have got. Okay, so I'm just going to do this one because this one takes a little bit of time. If we do the identity times B, we would do 1 times 3/4, which is 3/4, plus 0 times negative 2 over 3, which is 0. And then in this spot, we would get 1 times 6 over 11 plus 0 times 7 over 2, which is 0. Here you should get, if we do row 2 times column 1, you would get 0 times 3/4, which is 0, plus 1 times negative 2/3. And then in this next spot, we would get 0 times 6 over 11. We're doing this row times this column now. 0 times 6 over 11 is 0, plus 1 times negative 7 over 2. And what we get is 3/4, 6 over 11, negative 2/3, and negative 7 over 2. So you can see these two matrices are the same. The identity for a 2x2 matrix times B is equal to B. That's what makes it the identity for multiplication. It's called the multiplicative identity. Whenever you multiply something, you get the same thing. So here, I'm going to get A, and here, I'm going to get A, and here, I'm going to get B. So and with the identity, it doesn't matter which order you do it in. You're still going to get the other matrix, whatever you multiply it by. That's very useful for a lot of things. Okay, so now I want you to multiply these two matrices together and see what you get. So go ahead and pause the video, multiply these, and then come back. And I'm going to do it also. Okay, so if I multiply A times B, that's 2 times 3, 1, 2, 2, negative 3, negative 1, 2. Okay, I'm going to multiply this row. Let me use a highlighter. This row by this column. So 2 times 2 gives me 4, plus 3 times negative 1 is negative 3. Now I'm going to multiply row 1 times column 2, and I get 2 times negative 2 is negative 6, plus 3 times 2, which is a positive 6. Here, I'm now going to multiply, let me use a different color. Row 2 times column 1 to get row 2 column 1. 1 times 2 is 2. 2 times negative 1 is negative 2. And lastly, I'm going to multiply row 2 times column 2. And I'm going to get 1 times negative 3, which is negative 3, plus 2 times 2, which is 4. Now let's go ahead and simplify this. I get the identity. So when I multiply two matrices together, if I get the identity, that means these matrices are inverses of each other. So instead of A and B, I could have written A and A inverse. That's what this -1 up here means. It means the inverse. So it doesn't mean 1 over A. If you're used to that notation, it means the inverse. Okay, so A and B are inverses. That means if I multiplied B times A, I should also get the identity. So that's how you verify if two matrices are inverses of each other. If you need extra help, I am going to do this problem in the extra help video. But if you multiply these two together, you should get the identity, and then you can verify that they are matrices. So verify means these are inverses, but do the work to prove it. Okay, now we're going to move on to talk about the determinant. So I used letters here instead of numbers to just talk about the general term, and then I'll do an example in just a second. So to calculate the determinant of a 2 by 2 matrix, you take this first element, 1, 1, which I've called A, you multiply it by element 2, 2, which is D, you multiply A times D, and then you subtract this element times this element. So you do A times D, and then you subtract B times C. A times D minus B times C. So let's do that with an example. If this was my matrix, I would do 3 times 5 minus 4 times 2, which is 15 minus 8. So the determinant of this matrix would be 7. Now you might be asking, what is a determinant and what do we use it for? We use it for a lot of things, but one of the things is to find the inverse of a matrix. That's the most useful thing that we can use it for. So if the determinant of a matrix, we'll call this matrix A, if that is equal to 0, then there is no A inverse. A inverse doesn't exist. Okay? But if the determinant of A is not equal to 0, if it's anything else, then the inverse does exist. And that's a very useful thing. So what we're going to do is we're going to look at this matrix, and we're going to determine does this matrix have an inverse. So that's the determinant will help us determine if an inverse matrix exists. So let's calculate the determinant. That would be 2 times 3 minus 4 times 1. So 6 minus 4 is equal to 2. 2 is not 0. So if the determinant is not 0, then an inverse does exist. The inverse does exist. And we've proved it because the determinant is not 0. Okay, so I'm going to do this one in extra help if you need extra help on this problem. And let's move on to the second part. Okay, let me go back to the beginning. Pardon me. You're getting like a sneak preview of what we're going to do. Okay, so let me shrink this down a little bit because it's kind of going off my screen. Alright, so we have this matrix M. And what we want to do is find the inverse of matrix M. So first thing we want to do is calculate the determinant. We want to see, does the inverse matrix exist? So calculate the determinant. Let me make this smaller again. So what is the determinant? Try and find it on your own, and I'm going to go ahead and do that now. The determinant is -2. So again, I've got to resize it. Because if you do -2 times -4, you get 8, and then you subtract 5 times 2, which is 10, and you get -2. So the determinant of M is -2. Okay, so the next step is to finding the inverse, is you have to rearrange this matrix. I'm going to stop moving it because I've got a lot of these slides. But okay, so to determine the inverse, you find the determinant, and then you take these two elements and you switch them. Whoops, pardon me. Okay, so I take -2, -4, and switch them. Then I take the other two elements and I write their additive inverse, the opposite of those two. And so now what I have is this amended matrix. Here was my original matrix, -2, -4, and I switched those. Okay, so I switched the red, switched those, and then on the blue ones, I did the additive inverse. I changed the sign. So switch these two, change the sign on those. And so then you have this other matrix that's almost the determinant. So to figure out the, that's almost the inverse. Sorry, I misspoke. To figure out the actual inverse, you take that matrix. This was what I called M prime. That's how you say this when you have that little dash up there. You take this matrix and you multiply it times 1 over the determinant. So in this case, our determinant was -2. So 1 over -2 times this matrix where I've switched these two elements and changed the sign on those two, and I get -4 times 1 over -2 is a +2, -2 times 1 over -2 is a 1, -5 times 1/2, -1/2 is a +5 over 2, or 2.5, and then again -2 times 1 over -1/2 is, 1 over -2 is 1. So this is my inverse matrix. Okay, we could verify that these are inverse matrices if you multiply these two together and you get the identity. So go ahead and do that. Multiply this matrix, multiply M times M inverse that I have here, and see if you get 1, 0, 0, 1. And that's how you could verify that these are inverses. I'm going to do this problem in the extra help video if you need more, and this one. Okay, so now we're going to talk about how you can use the inverse matrix to solve matrix equations that have multiplication in them. So we're going to solve this equation. So let's say this is matrix A. Let's call this first one matrix A and the second one matrix B. So what we want to solve is this equation right here. A times X equals B. This is A, this is B. A times X equals B. So what we need to do to solve this equation, A times X equals B, is get rid of the A. We want X equals something, okay? And remember, these are all matrices. A, X, and B are all matrices. We know what A and B are, and X is what we want to find. So what we're going to use is the fact that we learned at the beginning of this, that if you multiply a matrix times its inverse, you get the identity. And if you multiply the identity times something, so let me do this. If you multiply the identity times X, you just get X. That's the definition of the identity. So we did that. That was the very first slide in this video. If you do the inverse, so we did 1, 0, 0, 1 times something, 2, 1, 1, 2, we'll do that. Then you get 2, 1, 1, 2. Okay, so you just get X. So we're going to multiply by the inverse of A on both sides to get rid of A. So if I multiply A inverse times A times X, then I need to multiply the other one by A inverse also. Here, A inverse times A is going to cancel out. That's going to give me the identity. And over here, we don't know what A inverse times B is yet. The identity times X is just X. So this is going to solve for X. If we multiply both sides of the equation by A inverse, then we solve for X. So that's what we're going to do. Alright, so we got to find A inverse first. So find the inverse of this matrix. I want you to pause the video and try and do that. And then when you come back, I will have okay, so here is A inverse. That's what you should have found for A inverse. You do -3, -3 and -2 and 3. You switch those. You change the signs on these two, and that gives you 3, -2, 5, -1. And then you multiply times 1 over the determinant. The determinant is -1. And so this gives you the opposite, which is equal to this. So here is A inverse. let's multiply both sides of the equation by A inverse. You can check to see that A inverse times A will give you the identity. And so we have x is equal to A inverse times B. So I need to solve what is A inverse times B. So that would be -3, -5, 1, 2. That's A inverse times B, which is -2, 2. This is what I want to solve. So let's go ahead and do that. -3 times -2 is 6. -5 times -2 is -10. So that first row is going to be 6 plus -10. Then if I do row 2 times column 1, I get 1 times -2 is -2. 2 times 2 is 4. So this is what it's going to be equal to, which is -4, +2. So that is what x is equal to, -4, +2. Alright, let me go ahead and clear this off, and let's test if that is true. If x is -4, +2, then that means that a times -4, +2 should be equal to b, -2, 2. So let's see. -2 times -4 is 8, plus -5 times 2, which is -10. 8 plus -10 is -2. 1 times -4 is -4, plus 3 times 2, which is 6. So this should give me -2, 2. And it works. So this is the solution. That's x. Okay, I'm going to do one more because that was kind of tricky. So the first step is to find the inverse. We have, again, a times x equals b. So to solve for x, we need to multiply by the inverse on both sides. Okay. Now, something important to notice is this and this are no longer equal. And you might be thinking, what? That's how you solve the problem. No, it's not. Remember, A inverse times B is not the same thing as A times B inverse. When we did matrix multiplication, we talked about this. Order matters. So if I multiply by A inverse on the left, and I multiply by A inverse on the right side of B, they're not the same thing. These are not equal. Okay? So over here on the left side of the equation, I multiplied by A inverse on the left. And so over here, I need to multiply by B on the left. So I don't write it like this. I write A inverse times B. If I do that, then the x will be equal to A inverse times B. Over here, the A inverse and the A cancel out, and this is what I'm left with. So this is what I'm solving for, A inverse times B. Order matters. So let's find A inverse. A inverse is equal to 1 over the determinant. The determinant is 3 times -5 minus -4 times 4. And then I'm going to multiply that by, I'm going to switch these two elements, -5, 3, and I'm going to change the sign on these. So if I change the sign on -4, and then if I change the sign on 4, so this is going to be my A inverse. So let's multiply. Well, first of all, what is this? -15 plus 16 is just 1. Okay, so if I multiply everything by 1, I get the same thing. Okay, so here is my inverse matrix. So to solve for x, x is equal to A inverse, which we found, times b. And b is 0, -22, 0, -28. So if we multiply this out, let me go ahead and write it like this. Row 1 times column 1 is going to give me 0. -5 times 0 plus 4 times 0 is 0 plus 0. If I do row 2 times column 1, I'm going to get the exact same thing. If I do row 1 times column 2, that gives me row 1 column 2 over here. So -5 times -22 is a positive 110. 4 times -28 is going to be a negative. 4 times 25 is 100, and 4 times 3 is 12, so this is going to give me a -112. I just did this. Instead of 4 times 28, I did 4 times 25 plus 3, which that's still 28, which is 4 times 25, and 4 times 3, which is 100 plus 12. That looks like 400. It's 100 plus 12. So that's how you do that in your head. Okay, and now I'm going to do row 2 times column 2 to get row 2, column 2. Negative 4 times 22 is a positive 88. And 3 times a negative 28 is going to be negative 84. So this is going to simplify to 0, 0, negative 12, positive 4. So that's what x is equal to. I'm going to do this one in the extra help video, and that's all for this lesson.